All right, we're back again. Now what we want to do is start to play around with our procedure that we've structured. And so we can start to consider some of the maths that we've actually got in here, and we can look at the way this procedure is working and try to generalize it a bit more. So what we're going to do is just get rid of some of the details. So we no longer want to just turn 90 degrees to the right. We're just going to say turn the tortoise and do the following. Let's change that to a number of times because we're going to change our numbers around. Okay, so if we think through some of the maths here, the reason why our tortoise turns 90 degrees is because it's a square. Now there's 360 degrees in a circle. A square has 4 sides or 4 angles. And so the 90 actually comes from 360 divided by 4, the number of sides. So let's just test that what I say is true. And we're going to put some maths in here because computers are really good at maths. So we don't have to do the maths. The computer can do it for us. So let's just say instead of actually turning 90, let's say turn 360 divided by 4. And then we'll run our procedure and check that the code works still. Beautiful. So it worked out that 360 divided by 4 was 90 and did the maths for us. So if we now want to change this around and say make a 6-sided shape, then all we should have to do is change the number of loops that happen and also change the angle that it turns. So let's say that we're going to go with 6 there and 6 there. We'll do a little experiment here and we're going to test whether or not we can now get a 6-sided shape happening by using the loop to run 6 times and the turn to work out the angle that it needs to turn when it turns 6 times. All right, let's press play. And you can see the angle has changed, so we're successful there. And we've got our shape working. Now, a couple of little gotchas. Let's try a shape that's 13 sides. So we'll go 13 there. And we're going to change the angle we turn by 13. Now you might notice here, let's see what happens when we say play. It's looking positive. Our 13-sided shape is in the process of being drawn. But you'll see that when we actually get to this point, our 360 divided by 13 hasn't given us enough to get all the way back. If we have a look at our maths, you'll actually see that 360 divided by 13, and let's fire up a calculator, 360 divided by 13, it's actually fractional, 27.6, and we are just dealing with integers in here, 360 divided by 13. So we need to tell the turtle that the fractional part matters. Now that's fairly easy. All we have to do is add a fractional part to our number. So if we say a decimal part to our number, so if we say 360.0 divided by 13 and then rerun our code, hopefully our turtle will actually work out that the decimal components of our number matter and we should get our shape fully completed. And we have. All right, so this is going to improve our accuracy, 360.0 divided by 13. Try creating some of those shapes yourself. So you could try with a 6 and a 13 and see how you go. Our next step is going to be to actually prompt the user. The turtle is going to ask the user how many sides it wants you, or you want it to draw, and then it will draw that shape for you rather than you have to change it in the code. So have a play around with those sides, and then we'll come back and add some more variables to make it ask you